For centuries, the boundaries of physics were strictly drawn around the tangible. The discipline was defined by observable matter, the kinetic collision of physical objects, or the predictable orbits of stars. When Michael Faraday first proposed the concept of an invisible electromagnetic field, his contemporaries openly mocked him. Because fields couldn't be touched or seen, critics dismissed his work as ghosts, a label for anything they deemed non-scientific. Yet the boundary of what we call physics evolved. Max Planck mapped the unobservable quantum realm of atoms, a domain that prominent scientists of his own era claimed sat outside the borders of physics. Today, the discipline is expanding again. MIT physicist Max Tegmark argues that physics is currently absorbing artificial intelligence and the mechanics of human thought. Science is not a static list of acceptable topics. It is an expanding framework that absorbs complex, seemingly magical systems the moment we successfully decode their underlying mathematical mechanics. Traditional computers operate on the von Neumann architecture, a hardware design that retrieves data by looking up a specific, explicit address on a hard drive. But human memory uses an associative model, allowing us to recall a complete concept from just a partial fragment of information. This diagram shows a Hopfield network, a model that describes associative memory using thermodynamic principles. It represents information as a 3D energy landscape, similar to an egg carton, where potential energy is plotted on the vertical axis to create deep, stable valleys. We can understand this mechanism by imagining a piece of data as a marble dropped into the landscape. The mathematical gradients naturally pull the marble downward toward the nearest basin. When you input partial information, like trying to recall the digits of pi, but only remembering 3-point-something, you are placing the marble near the correct valley. The system's dynamics automatically roll the marble into the stable minimum, retrieving the exact memory of 3.14159. By modeling memory as an energy landscape rather than a filing cabinet, physicists proved that intelligence can be described through physical laws. This realization earned researchers like Geoffrey Hinton the Nobel Prize in Physics. If algorithmic intelligence and memory retrieval are simply the dynamics of a physical system, only one major phenomenon remains outside the current bounds of hard science: human consciousness. Many scientists view consciousness as either identical to intelligence or untestable nonsense. This binary creates a massive blind spot in how we evaluate the systems we build. To study the mind physically, we must separate these concepts. Intelligence is the algorithmic ability to accomplish complex tasks and optimize towards specific goals. Consciousness is something else entirely. It is the internal, subjective, first-person experience of processing that information. This diagram shows their relationship as separate, intersecting variables. You can have intelligence without consciousness. Recognizing a friend's face requires massive mathematical data sorting. You accomplish the task perfectly, but have no subjective awareness of the unconscious algorithms used. Conversely, you can have consciousness without intelligence. In a vivid dream, you are immersed in a rich subjective experience, yet completely paralyzed in bed, accomplishing zero external tasks. Optimizing a machine learning algorithm to perfectly translate language guarantees nothing about its internal state. The assumption that a smarter AI automatically becomes a conscious AI is structurally flawed. If being intelligent doesn't make a system conscious, we have to isolate the specific type of mathematical information processing that actually generates a subjective experience. One leading framework is Giulio Tononi's integrated information theory. It proposes that a measurable mathematical property called integration, denoted by the Greek letter phi, is a necessary condition for consciousness. For an experience to feel like a unified self, data cannot be processed in isolated silos. If two neural networks operate in parallel without exchanging data, they cannot share a single conscious perspective. The information must be fundamentally and heavily integrated. The higher the level of interconnected routing, represented here by the rising phi variable, the more unified the subjective experience becomes. By defining consciousness mathematically rather than philosophically, we transform it from a ghost into a physical variable that can be tested in a lab. Skeptics argue that third-person scientific instruments can never rigorously verify a first-person internal feeling. They see a gap between the scanner and the mind that can't be crossed. But under Karl Popper's standard of falsifiability, a scientific theory doesn't need absolute proof to be valid. It simply needs to stick its neck out and risk being proven wrong by experimental data. To test the math of consciousness, researchers propose using magnetoencephalography, or MEG scanning. An MEG scanner is a high-density imaging device that maps magnetic neural activity in real time. In this experimental loop, raw brain state data is fed from the scanner into a computer running the integration formula. The computer analyzes the architecture of your neural processing and uses the math to make a prediction. It states in real time exactly what you are experiencing, predicting, for instance, that your mind is holding the image of a water bottle. This bridges the subjective-objective gap. By placing you inside the machine, the experiment turns the human subject into a biological logic gate, uniquely capable of verifying or rejecting the machine's mathematical prediction. The falsification criteria are incredibly strict. If the algorithm predicts that you are subjectively aware of your heartbeat, a purely unconscious process, you report false, and the theory is instantly destroyed. We already trust this method of theoretical extrapolation in other fields of physics. The ultimate example is Einstein's general relativity. Einstein's math was first tested locally by measuring the observable perihelion shift of Mercury. Because it survived those observable tests, physicists trusted its rules to predict unobservable phenomena, like the interior of a black hole. We can apply that same precedent to consciousness. A mathematical theory that repeatedly survives human falsification earns the scientific right to be extrapolated to non-human systems. Verified math will be the only way to determine if an unresponsive coma patient is secretly aware or if advanced AI architectures are actually experiencing subjective reality and suffering. We must reject the artificial pessimism of curmudgeon scientists who claim the mind is off-limits. Humanity has a consistent track record of looking at seemingly impossible boundaries and decoding them anyway. In 1942, Enrico Fermi ignited the first self-sustaining nuclear chain reaction. That small reactor was the canary in the coal mine. It proved the underlying physics was sound, leaving only the engineering. We have reached that same threshold with the science of the mind. Consciousness is the final physical system waiting to be decoded. The decision to mathematically test the mind places humanity at its most critical scientific fork in the road.